All right, so in this section, we are um, working on functions. So not the functions of determining if something's a function given a graph, a mapping, ordered pairs, or in a table. We're actually doing something with the function, giving an input and then getting an output out of it. So putting a number in and getting something out, so kind of like a vending machine. So I have two examples here. Given the function f of x equals 6x plus 2, what is the value of f of negative 2? So the reason why I'm saying f of, when you see f of x, just think of or that f parentheses x, just think of f of x, a function of x. All we have to do is substitute whatever number is in the parentheses with the x in the equation. Well, in this one specific, I'll put what I'm putting in. So here is f of negative 2 equals 6. Now what I said earlier here, I'm going to get the laser. Whatever number's in here, you're substituting it for the x. Well, there's an x next to the 6, so I'm going to put it in red. Instead of having an x there, I'm going to have negative 2. And since it's in the parentheses, we know we're going to be multiplying these two numbers. Plus 2. And then we're just solving some multiplication and some addition. Well, f of negative 2, just bring everything down, equals 6 times negative 2 is negative 12 plus 2. Negative 12 plus 2 is negative 10. So here, given the value of f of negative 2, given this function f of 6 equals 6x plus 2, if we input a negative 2 into this, we will get a negative 10 out. So we put in a negative 2, and we get out a negative 10. So that's how a function actually works given an equation. So not only are we building on what we learned last year and the lesson before about uh, able to determine what a function looks like, given those four things I said earlier, a table, map, graph, or ordered pairs, we're actually giving an input and getting an output, putting a number in and getting a number out. So let's look at the second one. Given the function f of g equals 1/2 g minus 6, what is the value of f of 14? So again, I'm not going to do as much writing as my previous one. All I'm going to do is rewrite everything, but instead of the letter G, we're now subbing in the number 14. So it's going to look like this. F 14 equals 1/2. Now again, not using G, we're using the number 14, and I'm just going to put that in red so you know. Now I didn't put it red in this side right here because, that's not really going to mess the equation up. We want to have the 14 here because this is where we're doing most of the math. And minus 6. Well, 1/2 times 14 is 7. And then just bring the minus 6 down, or negative 6. And then we have f of 14 equals 1. So again, with our input and what we get out, if we put in 14 in this function, we get out the number 1. So if there's any more questions, just come to class with those questions, please. We will get a little bit more in depth. Also, these numbers could be fractions, it could be decimals, um, they could really be anything. So make sure that they're not just always going to be integers. So pay attention to that. And we're also going to get a little bit more in depth with getting an output and having to find the input. So doing inverse operations, kind of like solving for x. So kind of things that we did at the beginning of the year, plus what you've learned the last 2 years, like 2x minus 4 equals 10. You know, having that output, knowing that output is 10 and finding the input, finding this number right here with inverse operations. So I have to add 4 to this side to cancel that out. So I have to add what I do to one side of the equal sign, I have to do to the other. So it's going to be 2x equals 14. And to get rid of this multiplication, or the 2 multiplying to the variable, I have to divide by 2. Remember, inverse operations. This gives us x equals 7. So, the output for this was 10, and we found the input by doing inverse operations. So we'll be practicing that, so you'll see some questions like that. But for right now, focus on getting an input and finding the output by substituting this number in, these two numbers into our equation. Thank you.